Okay.
All right, this is Algebra 2, Lecture 12.2 and 12.3, OAS A2A15. The student will solve radical equations and check for extraneous roots again. Just like we did with the last lecture, we're going to be squaring both sides of the equation, which will sometimes give rise to an extraneous root. And again, an extraneous root is a root that you derive from by solving the equation correctly, but the actual, when I say root and solution mean basically the same thing. The solution that you get, or one of the solutions, if you get more than one, may not work in the equation. That's called an extraneous root. You haven't done anything wrong, but that particular equation that particular solution doesn't work. So what we're going to do, I'm keeping these in my head. Last time I think there were 4 bulleted items on the lecture. Here there are only 3. We're going to square both sides of the equation. That tells me that the radicals are probably already isolated. And solve for the single variable. That'll be probably Algebra 1, maybe Algebra 2. And check for extraneous roots. That means we take our answer, plug them back into the original equation and see if it makes it true. So here we go. Oh, and when we're taking the square roots, when you take the square root within the context of an equation, like we've done in the past, we would say x, the square root of x squared is equal to 25. Take the square root of both sides and you get x is equal to plus or minus 5, plus or minus. But if you're just taking the square root of a value in the context of an equation that we're going to be doing today, just the square root of a number, we're looking for what's called the principal square root. So we're just wanting the positive value only. I'll point that out when we do it, if we do it. So here we go. Squaring both sides to get rid of the radicals, solving the equation, and checking for extraneous roots. Here we go. I'm going to square both sides because I have a radical equal to a radical. When I square both sides, both of these radicals disappear. That's nice. So now we have an Algebra 1 level problem. We have a variable on both sides of the equal sign. We don't want that. So what I'm going to do is, I personally like to keep my variables positive. So I'm going to add n to both sides, add 1n to both sides, and that will give me a positive variable over on this side. If I subtracted 3n, I'd wind up with negative 4n on this side. And that's okay. You can do that. You'll get the right answer. But I like to keep my variable positive because it's just one less thing to keep track of. So, just personal preference. I'm going to add n to both sides, add 1n. There's an implied 1 here. When I rewrite, this will give me 11. This is 0, n minus n is 0. 3n plus 1n, that's an implied 1. I just stuck it in there so you can see it. 3n plus 1n is 4n. Normally I don't write that in there, but it doesn't hurt to write it. Now I'm going to add 17 to both sides. What is that, 28? I just added 17 to both sides to get rid of that 17. And now I'm going to divide both sides by 4. And when I divide by 4, that'll give me 7 is equal to n. And then I plug it in and see if it works. 11 minus n, which is 7, is 4. The square root of 4 is 2. And that's the principal square root. We're talking about the positive square root. And if I plug in a 7 right here, I got 21 minus 17, that's 4. The square root of 4 is also 2. So this is not an extraneous root. And that worked out just dandy. Now let's take a look at another one here. Going to square both sides. Again, this is what's going through my head. I'm going to get rid of the radicals. I do that by squaring both sides. The square gets rid of the square root. They kind of undo each other. Then I'm going to solve the remaining equation for the single variable. It'll be probably Algebra 1 level or less, and check for extraneous roots. So here we go. I'm going to raise both sides to the second power. I'm going to square both sides. That will give me 2n plus 4 is equal to 6n. Those radicals disappeared when I did that. Now I'm going to combine, it's called gathering our variables. I want to get rid of I don't want to have variables on both sides of the equation, so I'm going to subtract 2n from both sides. This will yield 4 is equal to 4n. 6n minus 2n is 4n. I divide both sides by 4, and this side will turn into 1, and this side will turn into n. I said that's called gathering variables. It's called collecting variables. You'll hear it called that as well. We just move all the variables to one side using basic algebra. Then we plug this in to our original equation that's ignoring the squaring that we did and see if it works. So 2n is 2 plus 4 is 6. So that's the square root of 6 is equal to, if I plug in a 1 here, the square root of 6. So the square root of 6 equals the square root of 6. That's a true statement. And so we've solved it correctly. And I've got a key around here somewhere. I can just make sure that's right. So yay, so far so good. Now what we were doing here was a radical equal to a radical. A radical equal to a radical. When we do the next two, it's going to be a radical equal to a binomial. So when we go to square it, we're going to square a binomial, which means we're going to have to FOIL. Here I have a radical that's equal to a binomial. When I square both sides to get rid of this radical, I have to remember you can't just square both of these. This isn't k squared minus 64. A binomial square means a binomial times itself. K minus 8 times the quantity k minus 8. That's the binomial squared, the square of a binomial, equals, and this squared cancels out that radical, so to speak. I'm going to go ahead and FOIL this. K squared minus 8k. See if I can get rid of those. Then I'm going to take this negative 8 and distribute it. That minus sign is going to travel with the 8, so to speak. So that's negative 8k. I'm multiplying using the distributive property. Negative 8 times negative 8 is positive 64. And this is equal to 24 minus 2k. You don't actually have to write that part. You can leave it blank until we get down to the final bit. But here we go. Now I'm going to combine like terms. This gives me k squared minus 16k plus 64 is equal to 24 minus 2k. Now I want to subtract 24 from both sides and divide by 2. So here we go. I want to turn, this is a quadratic equation. I'm sorry, I was thinking without saying what I was doing. This is a quadratic equation, meaning the highest power of our variable is 2. And so we've done quadratic equations in the past, we've solved them, and we do that by setting the quadratic equation equal to 0. So what I'm going to do is turn this side into 0 by subtracting 24 and adding 2k. That was what was just going through my head. So here we go. I'm going to subtract 24. That turns that to 0. I'm going to subtract it from this because they're like terms. And I'm going to add 2k. That turns that to 0. So now this side is 0, and I've got to add 2k over here. And that gives me k squared minus 14k plus, what is that, 40? Is equal to this fancy 0. And now I'm going to try to factor this puppy. As we learned when we were solving quadratics earlier, square root of this one here and here. The factors of 40 that add up to 14 would be 10 and 4. Doesn't matter where I put them. What matters is they have to add up to negative 40. And the only way that could happen is if they're both negative. And then I look for values. I use the zero product property. You should remember that from when we did when we were solving equations earlier. I'm going to scooch this down just a little bit. Zero product property says if this chunk, this factor, times this chunk, which is a factor, if this factor times this factor is 0, one of these factors has to be 0. If this one is 0, that means k has to be positive 10. Positive 10 will turn this to 0. Positive 4 will turn this one to 0. And then I check to see if either one of them is extraneous. So I'll plug in the 10 first. 10 minus 8 is 2. 24 minus 2 times 10, that's 24 minus 20, which is 4. The square root of 4 is 2. So the 10 works. Yay. Remember, if we take the square root of a number, we're looking for what's called the principal square root, the positive square root. So here we go. We'll plug in the 4 and see what happens. K minus 4 is negative 4. I'm sorry, k minus 8 is negative 4. So this side turns into negative 4 is equal to 24 minus 2 times 4, which is 8. 24 minus 8 is 16. The square root of 16, the principal square root is 4. This side turns into negative 4. So this is an extraneous root. It's not a solution. So we only have one solution to this, even though we didn't make any mistakes. We got two solutions and one of them was extraneous. And the only way we can find that out is to plug it back into the original equation and see if it makes it true. This one didn't. Remember, we're looking for principal square roots. When we take the square root of a number, we just want the positive value. Okay, let's take a look at this one. This is going to be the exact same technique. We have a binomial is equal to a radical. So I'm going to get rid of this radical by squaring both sides. This side is going to turn into 4n plus 8 without the radical symbol. And I'm going to do this part in my head. Okay. Squaring this binomial n plus 3 times n plus 3, foiling it and combining like terms and coming up with this. I'm going to do that in my head by just saying, well, that's n squared plus 6n plus 9. I've just done a bunch of these, and that's what you will get if you multiply that by itself, FOIL, and combine like terms. You get n squared plus 6n plus 9. That'll just speed us up just a little bit here. But the technique is just this. Multiply this by itself and FOIL and combine like terms. Now, I want to set this side equal to 0 because this is quadratic. And when we solve quadratic equations, we want one side to be 0. So I'm going to subtract 4n from both sides. That gives me n squared plus 2n plus 9 is equal to, I can go ahead and subtract 8 at the same time. So 9 minus 8 is 1, isn't it? I've just turned this whole side into 0. I subtracted 4n, that gave me 2n, and I'm subtracting 8, and that gives me 1. So this side turns into 0, and now I can try to factor. If it won't factor, I'll use the quadratic formula, but this will factor. All of yours today will factor. Square root of this one here and here. Factors of 1 that add up to 2, well, that would be 1 and 1. And they have to add up to a positive 2. So, and now I employ the zero product property. If this factor times this factor is 0, one of these factors has got to be 0. Well, they're identical. So I could do it twice, but I'll get the exact same answer. Either n plus 1 is 0 or n plus 1 is 0. And n is equal to negative 1. You subtract 1 from both sides, and you'll get the same thing here. So there's only one root to this equation, one solution, and I'm going to plug it in just to make sure it works, and make sure I haven't made a mistake, because Lord knows I make mistakes. Like when I did this, in my head I may have made a mistake. So let's see, this will be 2. If I plug in negative 1 right here, negative 1 plus 3 is 2. Plug in a negative 1 right here, that gives me negative 4 plus 8 is 4. The square root of 4 is 2. So this does work. So what are we doing today? We've got a situation where we have a radical equal to a radical. We square both sides, solve the remaining algebra 1 or pre-algebra equation, and then check for extraneous roots. Squared both sides. that got rid of the radical symbols, solved the remaining, we collected our variables, solved the remaining equation, plugged it in and checked it. This one was radical equal to a binomial, so we squared both sides. We have to multiply the binomial by itself by FOILing and combining like terms. Then we turn the other side, the quadratic side, we're going to leave it, we want our quadratic term positive, so I'm leaving it here, turning the other side into 0. I subtracted 24 and added 2k, combined like terms, and then said, okay, here's my quadratic equation set equal to 0. I'm going to factor it and use the 0 product property. If this times this is 0, then either this one is 0, which means k has to equal 10. Plug in a 10 right here, 10 minus 10 is 0. Or this one is 0, which means that k has to equal 4. 4 minus 4 is 0. And we did the same thing over here, except I did this first step in my head. I did this bit in my head. Okay? And if you can do it in your head, go for it. You can do this.